Welcome back. In these next few slides, we'll perform the Z transform of an un, where un of course telling us that the sequence is causal, n will go from 0, 1, 2 until infinity, and a is a constant. So this is a geometric sequence. And when we use the Z transform, you convert the geometric sequence into geometric series. Let's plug in the sequence an into the Z transform. When we plug in an into the Z transform, we convert the sequence into a polynomial. This is a polynomial of negative power. Let's first convert this expression az minus 1 into r equals to az minus 1. So this guy is r squared, which is az minus 1 squared, a squared z minus 2. And then the third guy, of course, is r cubed, is a cubed z minus 3, and so on. So what we see is we have a geometric series 1 plus r squared plus r cubed. We know the solution to a geometric series. It is the sum as it goes to infinity is 1 over 1 minus r if absolute value of r is less than 1. So this is the answer, 1 over 1 minus r, and this expression is r. A over z must be less than 1. Therefore, z must be greater than a. Remember that we do not like to use negative powers of r sometimes. We will multiply top and bottom by z, and we'll get z over z minus a here. So this slide shows us the Z transform of a to the power of n. If you want to verify using MATLAB, again start MATLAB, use the symbolic expression to tell MATLAB n, a, small f and capital F are symbols. Express f as a to the power of n. Perform Z transform. So MATLAB will use the unilateral Z transform, and we'll get Z transform of f will give us this value. Z over a minus z, and there is a negative in front, so please check for yourself that the negative sign can be brought inside, and we'll get z over z minus a as well. With that, now we want to study for the case when a equals to 1. When a equals to 1, implying 1n un, and this reduces to un. So what would you get? Of course, when a equals to 1, all you need is to say replace the small a by that. You will get z over z minus 1. And then the ROC is absolute value of z must be greater than 1. So here it is. This is un minus naught, a delayed version of un. And now let us begin with, let's ignore the n naught first, and let's find simply the Laplace transform of un. We do not even need to go through this. We just take the previous expression and substitute the Z transform equals to z over z minus a. We substitute a equals to 1, and with this new ROC, z greater than 1. So now we have dealt with the two most standard functions of Z transform, which is Z transform of a to the power of n and Z transform of un. Thank you.